Have you ever wondered how capacitors work in your electronic devices? Well, capacitors are pivotal components in the vast world of electronics. These nifty devices play the essential role of storing and releasing electrical energy, acting much like a mini battery within circuits. From your mobile phone to your refrigerator, capacitors are the unseen heroes that keep your devices humming. They're integral to the operation of most, if not all, electronic devices. So fasten your seatbelts as we delve deeper into the world of capacitors. A capacitor may seem complex, but its structure is fairly simple. At its core, a capacitor is made up of two conductive plates. These plates are not directly connected to each other. Instead, they are separated by an insulating layer called a dielectric. This dielectric can be made of various materials, such as ceramic, glass, or even paper. So what happens when voltage is applied to this setup? An electric field is generated between the two plates. This field causes a buildup of positive charges on one plate and an equal amount of negative charges on the other. This charge accumulation is what we refer to as capacitance. The strength of the electric field, the size of the plates, and the type of dielectric used all influence the amount of charge a capacitor can store. This makes capacitors incredibly versatile and adaptable to various electronic needs. That's the basic structure of a capacitor. Simple, isn't it? But how does it work? Let's explore. So, how does a humble capacitor do its job? Well, let's dive right in. When a voltage source, say a battery, is connected to the capacitor, something fascinating happens. Electric charges start to build up on the plates. The positive terminal of the battery attracts negative charges to one of the capacitor plates, while the negative terminal of the battery attracts positive charges to the other plate. Now, these charges don't jump from one plate to the other. No, they stay put, creating an electric field within the capacitor. This electric field is essentially stored energy, ready to be released when required. Think of it as a tiny reservoir of electrical energy. When the capacitor is connected to a circuit, this energy is released, powering the circuit or device. The capacitor, in a sense, acts like a temporary battery, storing and releasing energy as needed. Now, you might be wondering, how much energy can a capacitor store? Well, that's a great question. The amount of energy a capacitor can store is dependent on a few factors. One of these factors is the material between the plates, known as the dielectric. Different materials have different abilities to store electrical energy. For instance, air or vacuum has a lower capacity to store energy compared to ceramic or plastic. Another factor is the size of the plates. Larger plates can store more charges, which means more energy. But remember, larger capacitors also take longer to charge and discharge due to their increased capacity. It's all about finding the right balance for the specific application. So, to sum it up, a capacitor works by storing electrical energy when connected to a voltage source and releasing it when connected to a circuit. The amount of energy it can store depends on the dielectric material and the size of the plates. And that, in essence, is how a capacitor works. But there's more to it than meets the eye. Capacitors are not just theoretical entities. They are hard at work in our everyday devices. These miniature powerhouses can be found in a wide array of applications. Let's take power supplies, for instance. Capacitors smooth out voltage fluctuations, ensuring a steady, consistent supply of power. Now, consider your favorite radio station. How do you suppose it tunes into just the right frequency? Yes, you've guessed it, capacitors. They're vital components in radio receivers, enabling them to hone in on specific frequencies amongst a sea of radio waves. And let's not forget about audio equipment. Whether you're blasting tunes on your home stereo or quietly enjoying your favorite podcast on earphones, capacitors are there, diligently working to filter out unwanted noise and ensure crisp, clear sound. Capacitors also act as energy reservoirs, storing power and releasing it when required. So, the next time you use an electronic device, remember the tiny capacitors working tirelessly to make it function smoothly. So, to sum it all up, capacitors, with their two conducting plates and insulating medium, play a crucial role in storing and releasing electrical energy. Their function relies on the simple yet fascinating principle of charge accumulation. Whether it's smoothing out voltage in a power supply or tuning into your favorite radio station, capacitors prove their worth in a multitude of applications. And that's a wrap on capacitors. Don't forget to like, share, and subscribe for more intriguing insights into the world of electronics. Until next time, keep exploring!